Play with a token on a board with grid. It starts at 0, 0 and moves in steps. It's either 1 in the positive X direction, probably 0.8, or 1 in the positive Y direction. Okay, so we've got, and it stops when it gets to Y coordinate of 1. So it starts there and it goes to 1, and that's the probability 0.8, and that's probability equals 0.2 going that way. 1, 2, 3, 4. Okay, it goes like so. Finds, and it's given that the token stops at x1. Find out the probability x equals 10. So that's 10. It will stop there. So for the first part, I've got to work out the probability that x equals 10, and that means I will have to have got all the way across to here first and then up to there. So that's going to be, I've got to have 10 sort of going in this direction, so that'd be 0.8 to the power of 10, and then finally I've got to go get the y coordinate 0.2, and that would be 0.02147836, and that equals 0.0215 to 3 significant figures. Part B, find the probability that x is less than 10. Probability x less than 10. I always like saying what it is. That means it could be 0, 1, 2, all the way up, 7, 8, 9. It can't be 10. And so this equals 1 minus the probability that x is greater than or equal to 10. Because that could be 10, 11, 12. And if it's going to be, x is going to be greater than or equal to 10, that means I must have got to here. And so that means I've got to have 0.8 probability each time until I get to 10, so that'll be to the power of 10. And that equals 0.892628, which equals 0.893 to 3 significant figures. Part 2, 3. Find the expected number of steps taken by the token. And the number of steps is a geometrical thing, so it tells geometrical, and probability of success in this case is 0.2, and so the expectation of number of steps equals 1 over p, which equals 1 over 0.2, which equals 5, and hence write down the value of the expectation of x. So steps is the whole way until I get a y, and so the expected value of the x will be 1 less than that, because the last one is going to be the y, so that will be 4. And that's question 9 and the whole paper done.